Lawrence. I'm a final year student in Manipal International University, where I'm pursuing my degree in computer engineering with honors. So today I'll be presenting our paper on the recent trends and opportunities of remote multi-parameter PMS using IoT. And this paper was co-written by me and my classmate Rajiv Suresh Nair. So this presentation will comprise of the introduction, the problem statement, the previous works, the proposed system, and the conclusion. There are 1.4 million people in assisted living in the US. These people are in need of constant supervision and need to be monitored constantly 24 hours a day so that they can get the medical assistance that they need in their times of need. So with an RPMS system, or a remote patient monitoring system, these people can live in the comfort of their homes while still retaining the benefits of living in an assisted healthcare and while reducing the expenditures that they would otherwise need to be enrolled in such facilities. So patient monitoring system is a collection of sensors and software that can monitor a patient's vital signs. And these are traditionally present on site at hospitals or clinics. However, they can be implemented remotely using IoT implementations. This includes using smartphones, computerized systems, wearable devices, or biosensors, and so on and so forth. So PMS, or a patient monitoring system that can be set up in a home environment or outside of a hospital environment, is called a remote patient monitoring system. Patients do not need constant attention, however, who need to be monitored constantly, find themselves in use of an RPMS system. This allows their users to be discharged from the hospital early and can be monitored and checked on from their homes. So RPMS systems enable the real-time detection of illnesses. It enables patients to be continuously monitored. It prevents the worsening of illnesses, and it reduces the cost of hospitalization. So the way this works is that it has sensors that collects data about a patient's vital signs, such as heart rate or blood pressure, and it transmits this data to a server where it's recorded or further processed. Then this recorded data is used by doctors to make decisions or recommendations on the patient's condition. Medtronic PLC found that they were spending $100,000 per annum for the maintenance and implementation of RPMS devices. So as we can see, this is an obvious problem. It is extremely expensive to use, and furthermore, these systems have limited accessibility. So this brings about the need for a low-cost but effective substitute for these high-level technologies. And therefore, we propose a remote multi-parameter PMS based on the SVM, or support vector machine algorithm, in machine learning. So in order to make this paper, we had to review several literatures, of which I will cover two for the purpose of this conference. So one of the papers we reviewed involved the use of an Arduino Uno and GSM-based wireless. So here, the system monitored a patient's heart rate, temperature, and sweat levels with the respective sensors using an Arduino, and then transmitted them via SMS using a GSM modem to the doctor. So this can be seen in the block diagram above. However, the limitations of this system is that it requires an active GSM connection rather than a Wi-Fi connection to transmit data. And furthermore, there was no interface to check the readings or to host live checkups. Another similar system used an Ethernet shield. However, another limitation of this system was that data transmission was wired, and the Arduino Uno needed to be plugged in to transmit data. And furthermore, the interface could only monitor the patient. It didn't provide any checkup or any notification services. And therefore, we bring into play our proposed remote multi-parameter PMS system. It's a low-cost remote patient monitoring system, which uses the support vector machine, or the SVM algorithm, which is a machine learning algorithm that can be used to determine the patient's condition by monitoring their stable state. So this system would provide notifications to the affiliated hospital or clinic when the readings from the sensors are undesirable or not ideal. So the interface would also allow healthcare providers to access the patient's records, and there would be a video conferencing functionality that would allow healthcare providers to conduct checkups. So the monitoring component would be set up and connected to the local Wi-Fi at the patient's home. This would allow doctors to also access the patient's biotelemetry or the patient's bio data through the web interface accessible from their computers. And it would also allow them to receive automatic alerts through the same interface if the patient's condition worsens. So to condense some of the features of our remote parameter PMS remote multi-parameter PMS as we saw earlier, it has real-time tracking of the biotelemetry of patients. It can adapt to each patient using machine learning algorithms. It can provide automatic alerts to hospitals when the patients need attention. And it's got video conferencing support for online checkups. So this section I would describe how our system works. So as we can see, the patient would be connected to an Arduino consisting of sensors. And these sensors would be constantly monitoring the patient's vitals for blood pressure and oxygen and temperature and so on and so forth. Then this sensor data would be sent to the Python Flask application that is hosted on a web server, which would perform the machine learning processes. So the sensor data would be recorded. The data would be compared against normalized confidence values, and the machine learning algorithm would have been pre-trained with data from localized data sets, against which the patient's sensor data would be compared. So if the reading is abnormal, or if the reading does not fall within the normalized threshold, then it notifies the doctors or the authorities at the hospital about the patient's abnormal condition. However, if the patient's condition is normal or falls within the normal threshold of confidence values, then the system would store this data and use it to train the algorithm, which is an advantage of the SVM algorithm, or the advantage of using machine learning in our system. It would help tailor the system to each patient to improve the accuracy levels of the system over time and with more and more repeated use. So furthermore, the system would also be able to generate graphical representation of the sensor data, which would be accessible via either the hospital authorities, the medical authorities, or the patient through their devices like a desktop or a smartphone. So moving on to the advantages of the remote multi-parameter PMS. It is cost effective. It can be implemented at home. It uses the SVM algorithm to adapt to the patient. It can monitor up to 5 parameters. It notifies the hospital when the patient needs attention. And it provides an interface for doctors to check up on patients. So the components of the remote multi-parameter PMS includes a monitoring system, which has an Arduino Uno, a Node MCU Wi-Fi module, and the sensors, a web server, and a communication interface. So the microcontroller used in our monitoring system is the Arduino Uno. It would receive data from the connected sensors and transmit this data to the web server using the Node MCU Wi-Fi module. The web server used in our system would be the HEROKU cloud platform, which is used to host programs and scripts. It would receive data from the monitoring system. It would process it using the machine learning algorithm and classify the readings either as desirable or undesirable. And it would host the communication interface. And finally, the communication interface, or the web application, we would use the Flask microframework to build. So this is a Python-based web microframework that would have an interface that provides users with access to the records and would allow communication between the doctor and the patient. Furthermore, it would allow regular checkups to be done remotely. And so finally, to conclude, patient monitoring systems are essential for the safe recovery of a patient. Remote monitoring systems provide monitoring outside of traditional settings. This helps to reduce deaths caused by negligence. So our proposed remote multi-parameter PMS aims to fulfill the above and it aims to provide a monitoring system that is tailored to each patient, that can help reduce travel and hospital costs, and that would be effective and cost efficient to implement. Thank you for your time and attention.